Welcome to our fourth and final installment of our ecology unit. Today is all about climate change, what it is, what it's caused by, how we can prevent it, all that good stuff. So before we can get started about talking about climate change, we need to know what causes it, and for that we need to know about the greenhouse effect. So the greenhouse effect is a natural process. This should be happening. The reason why Earth is inhabitable is because we are able to, the Earth is able to absorb radiation from the sun and re-emit it, and then keep it enclosed within the Earth's atmosphere so that we can retain the heat. The way that this happens is short waves are sent from the sun to the earth, and then the earth absorbs this shortwave radiation and re-emits it as long waves. Once the long waves get pushed back into the atmosphere, the greenhouse gases, which we'll talk more about on the next slide, the greenhouse gases absorb that and re-radiate the longer wave radiation back, which allows us to retain the heat in the atmosphere. So this idea is the sun is sending these wavelengths down, they're being bounced out into the atmosphere, and the gases that are in our atmosphere are absorbing and re-emitting those, keeping them within the atmosphere, which also allows the heat to stay in the atmosphere. By doing that, it makes it so that the Earth is able to maintain life. If we were unable to keep this heat from the sun in our atmosphere, we wouldn't be able to live on Earth. It would be freezing. So it's a massive process, and it's absolutely vital to our survival. However, as you will see, there is a fine line between having greenhouse gases in the atmosphere to maintain heat and having too many greenhouse gases in the atmosphere, which leads to global warming. So the greenhouse gases that we're going to talk about are water vapor, carbon dioxide, methane, and nitrogen oxides. We've already talked a lot about some of them, but this is just kind of a good overview. So this first bullet, again, is just talking about how heat is kept in the atmosphere. Now let's talk about the two greenhouse gases that are responsible for the largest amount of this warming effect. So water vapor, aka clouds. So you get water vapor in the atmosphere from evaporation and transpiration in plants, and then it can be removed from the atmosphere via precipitation, right? Clouds don't stay forever. Eventually it rains. Carbon dioxide, I think we've talked enough about this, but right, you get a lot of CO2 in the atmosphere by cell resp and burning fossil fuels. And plants are able to remove carbon dioxide from the atmosphere because they need it for photosynthesis. The two other ones, while still a greenhouse gas, are not the largest warming effect. So these are still important to know, but if asked what are the two most compromising gases in our atmosphere that lead to global warming, the answer would be water vapor and carbon dioxide. So talking about methane, we talked about this, right? It's emitted from these kind of waterlogged areas, the mud on lakes, cows, sheep, goats. So that is emitted into the atmosphere, but it doesn't stay very long in the atmosphere. And then nitrogen oxides, they're just kind of naturally released by bacteria, can also be released by cars or other vehicles like trucks. Let's talk about the impacts. So the impacts of greenhouse gases, there's kind of two main ways to determine how much of an impact a greenhouse gas is going to have. Number one is its ability to absorb long wave radiation. So if its ability to absorb this radiation is higher, that means it's going to release a higher warming impact. So if it can absorb more, it's going to make more heat. And then the concentration of that gas within the atmosphere. If it has more of a concentration, that means it has a bigger impact. The concentration, like to determine the concentration of a gas in the atmosphere, is determined by two things, and they work together. So it's determined by both at the same time. So the rate of releases, so how quickly it's released from the earth into the atmosphere, and how long it persists in the atmosphere. So, for example, methane. We talked about this last time. Methane is released quite a bit and quite frequently from the earth, but it doesn't stay very long in the atmosphere. So although it's released a lot, it doesn't have a huge impact as much as, say, water vapor or carbon dioxide, because it doesn't persist as long. So you have to look at both to be able to determine which has the greater impact. Some of the consequences of global warming, and this is not like brand new information, I'm sure you've heard this before, but it can increase disease, the ice caps are melting, weather conditions are out of control, and I'm sure you've seen this in the past couple of years. We've had quite a few devastating hurricanes in the south of the United States, as well as in the Caribbean and all around that area. So extreme weather, extinction of animals because they cannot survive in this new world with all of these changes, acidification of oceans by making oceans more acidic, that is causing extinction, so some organisms can't live without the coral reef. Sea levels are rising, which can also lead to horrible outcomes for humans, because now all of the people that live on the shores of various countries, that area of land is underwater now, and so they can't live there, which then pushes everyone inland, which there's just so many people on Earth that there's just not enough room for everybody. Temperature increases, and then habitat destruction. CO2 concentrations, this is, again, we talked a lot about this last time, just briefly covering it again. The amount of carbon dioxide that's in the air can directly be related to man. Man is influencing this emission in a lot of ways, but the three biggest ways is deforestation, increased farming, and then combustion. So deforestation, removing the ability to take CO2 out of the air by removing plants, increased farming, which pushes methane back into the atmosphere at alarming rates, and then combustion, burning of fossil fuels. So we've talked about this before, but these are still a good thing to write down, especially as a review, to make sure that you're getting the main pieces of this. Your carbon footprint. If you took environmental with Ms. Clausen, then you might know this. The carbon footprint is the total amount of greenhouse gases produced directly and indirectly from human activity. So you can figure out your own carbon footprint to see how much CO2 you personally are emitting. It's a really good way to kind of visualize exactly what you're doing. This can be from taking long showers. It can be from driving everywhere, even though you and a friend go to the exact same place. You both take your own car. Usually, if you want to reduce your carbon footprint, the age-old saying, reduce, reuse, and recycle, that is mega important. It's important to be thoughtful and conscious of what you are doing and how your actions impact the environment and those around you. Now, while this is mega important and you should absolutely be reducing, reusing, and recycling, I want it to be clear that the reason that there is so much CO2 in the air is you cannot blame that strictly on individual humans. Companies, you can name like big oil companies, and they're producing so much more carbon than any one individual is doing. So while it's mega important that you do your part, it's also really, really important that companies start to understand the role that they're playing in pushing all the CO2 and what their role is in global warming. So climate change. We've talked about this, you've talked about this, that none of this is new. I'm hoping that this is all review for you, because this is stuff that's in the news all the time, and frankly, you should be aware of what's going on on around you. So climate change is this idea that because the concentrations of greenhouse gases are going up, the global temperatures are also increasing. So because of this, we see all these other impacts, like the weather patterns are weird. You see the oceans acidification is causing extinction, all of that. We know, we have seen evidence, and specifically from the Vostok Ice Core, that there is a strong correlation between the increase of CO2 levels and the increase of global temperature. We've seen in the past using these ice cores that as the Earth went through ice ages and periods of warming, that there was a direct correlation of the amount of CO2 in the atmosphere. At this point in time, the CO2 concentration is higher than ever. In the past 400,000 years, our CO2 levels are the highest they've ever been. This is serious, and it's a massive issue that does not have the support of businesses and some politicians, and it's frustrating personally as a scientist to see this because of all the evidence that is pointing in this direction that climate change is a man-made problem. We've also seen that there's a positive correlation, especially within the last 200 years due to the Industrial Revolution. So as we've started using machinery more, burning fossil fuels more, we've seen the increase of carbon dioxide levels. We've talked about this in the last one, so if you want a more in-depth version of ocean acidification, I suggest you re-watch last video. But because of the CO2 in the atmosphere increasing, that means the dissolved CO2 in the ocean is also increasing. As the carbon dioxide matches with the water, you get carbonic acid, and as that breaks down, you have hydrogen ions floating in the water, which increases the acidity of the ocean because of all those extra hydrogen ions. At this point, in the last 200 years, the ocean pH has dropped a tenth, 8.2 to 8.1, and with that is a 30% increase in acidity. At this point, it's predicted to drop to 7.8 in the next 80 or so years, which is massive because in 200 years it dropped from 8.2 to 8.1, and we're talking in less than 100 years, it's predicted to drop from 8.1 to 7.8. If it drops that low, it will be devastating for the organisms in the ocean. Shells, the coral reef, exoskeletons, everything's going to begin to dissolve. And by doing that, you're not only going to lose the shelter and the habitat of many marine organisms, but you're also going to lose all the shoreline protection for humans. Coral reefs are beneficial for humans too. Think about how many people travel just to see coral reefs, and if they don't exist anymore, all of that revenue that countries depend on from tourism, gone. And invasive species, once they have a way in, it's very difficult to get rid of invasive species. And if there's no, your typical organisms that would be in that niche, if they're not there to defend their area, then invasive species are going to come in. And because there's so much CO2, that's going to increase photosynthesis, which allows the amount of food available to not diminish, which means that any invasive species that comes there is not going to have to fight for their food because that's not going to be an issue for them. This is just another picture which kind of is just a visual of what I was just saying. You can see here that as the CO2 in the atmosphere increases, the ocean acidity decreases or gets more acidic. And then this is just kind of showing the shell deterioration from this is what it would look like normally. And as you go through the days, as it starts to dissolve and deteriorate. Okay, this is kind of the last big piece that I'm going to talk about, but these two ideas, the precautionary principle versus the burden of proof. So, the precautionary principle is basically the idea that when a human induced activity is starting to show a threat, you need to take measures even if there is not a scientific consensus. At this point, 97% of scientists agree that global warming is man made. But because that number is not 100%, there's always going to be people that say, well, not everyone thinks it's man made. So the precautionary principle is this idea that even though there's not a 100% scientific consensus, because there's a significant threat, we should be taking measures to prevent that. Okay? So it's kind of like trying to stay on top of things even if you don't know if it's going to be a bad thing. Whereas burden of proof is the opposite of that, which states that you should do nothing until you are absolutely 100% sure of what the cause of that harm is. Okay, so this is like being on the offense versus being on the defense. So precautionary principle is on the offense, you want to prevent things from happening. Burden of proof is, okay, well, now that we know this is actually happening, let's start doing something. The last bit is just, I'm not going to read all of this, but I just want you to be aware that a very common question is to debate the greenhouse gases effect on climate change. So this is the idea of there are people who agree that greenhouse gases and humans are responsible for climate change and those that don't agree. And so here is a bunch of arguments, both for and against. And it's just a really good way to kind of have all of this. I would suggest pausing this if you want to use this at any point, but on the next slide, there's even more. I am telling you that it's almost a guarantee that you will see this question in some form, that you should be able to argue both for and against whether climate change is caused by humans. It's almost in every paper, and even if you think you know all of the bits, you should probably write a few down just to make sure that you actually know what you're talking about. All right, that's the end of this slideshow, this presentation. So thanks for sticking with me, and I'll see you next time.